Okay, so today we are going to talk about how to correctly solve for missing sides in a 45, 45, 90 triangle. As you can see here, we have a square because it's marked with 4 congruent sides as well as 4 right angles. So to create our 45, 45, 90, the first thing that we are going to do is we are going to draw a diagonal through this square. So I draw a diagonal from the upper left corner down to the to the lower right corner. And what this has done is bisect the opposite angles. Which, as we know, bisects means split in half. So now these once 90-degree angles have been split into 45-degree angles. So now I have created 2 45, 45, 90 triangles. All right, so then just like yesterday, we are going to need to solve for missing sides. Now, I am going to, just like yesterday, label one of my legs X. Remember, these would be considered the legs over here and here, while the diagonal would be considered our hypotenuse. Now, in this particular case, since my angles 45 and 45 are congruent, that should mean that the legs or the sides across from them are also congruent. So if I label one leg X, since they are marked to be congruent, I should also label this leg X. Now, I don't know what to label my hypotenuse, but we can use Pythagorean theorem to find the hypotenuse. So that's exactly where we'll start. So we know to label our legs A and B while our hypotenuse is C. So in our Pythagorean theorem, we are going to have A squared, which is X squared, plus B squared, which is also X squared, will be equal to our hypotenuse squared, which is the piece we're looking for. X squared and X squared are like terms, so I can add those two together to get 2x squared is equal to the hypotenuse squared. Now I am looking for just the length of the hypotenuse, so to get rid of that square, I'm going to take the square root of both sides, which would leave me with the hypotenuse is equal to square root of 2x squared. We do want to simplify that if we can. There is no square root of 2, so that's going to have to stay under our radical. But there is a square root of x squared. The square root of x squared would just be x, so it can come out from underneath that radical while the 2 is left behind. So now I know to label my hypotenuse x square root of 2. All right, so now from here on out, anytime we have a 45, 45, 90, I'm going to label the legs x and x while I'll label the hypotenuse x square root of 2. So here's another 45, 45, 90 triangle. Again, we will label the legs x and x, while we'll label the hypotenuse, which is across from the 90-degree angle, x square root of 2. We do need to memorize that that's where those values will go and what those values are. All right, so now let's apply that to some examples. So on example 1, the first thing we're going to do is go in and label all the sides. So we label our legs x and x, while we label the hypotenuse x square root of 2. In this particular case, they gave us a leg. They said that that leg was 5, therefore we know that x is equal to 5. Well, if x is equal to 5, I can substitute that in for this side down here. Side AB must also be 5, while my hypotenuse should be 5 square root of 2. All right, so let's look at another example. Flip it over onto the back. Okay, so the first thing we want to do is label our sides. So our legs, x and x, our hypotenuse, x square root of 2. This time they gave me the hypotenuse. So I know that the hypotenuse, or x square root of 2, is equal to 4, and we need to solve for x so we can find the lengths of the other two sides. So just like yesterday, this reads as x times the square root of 2. So to get rid of the square root of 2, the opposite operation would be to divide. So x is equal to 4 over the square root of 2, but we don't like to leave a radical in the bottom. So I am going to multiply by square root of 2 in both the denominator and in the numerator. So in our numerator, we've got 4 times the square root of 2, which would just be 4 square root of 2, over square root of 2 times square root of 2, which would just be 2. Now this 4 and 2 will simplify, so we are left with 2 square root of 2 for our value of x. And since both sides, AB and BC, are x, both of them have a measure of 2 square root of 2. All right, let's look at another example. Again, the first thing we should do is label our sides. So I have x and x for my legs, and x square root of 2 for the hypotenuse. So again, we were given the hypotenuse, meaning that x square root of 2 must be equal to 3 square root of 15, and I just need to solve for x. So to get rid of that square root of 2, we have to divide both sides, but we still have to rationalize the denominator. So I'm going to end up with x is equal to 3. Since these numbers are both under a radical, I can multiply them, which would give me square root of 30 over 2. 3 is not divisible by 2, nor can the square root of 30 be simplified. So our value of x is just 3 square root of 30 over 2. And since both sides AB and BC are x, that is going to be the value for both of these side lengths. All right, last example. Again, first thing we should be doing is labeling the sides. So my legs are x and x. My hypotenuse is x square root of 2. So this means that x square root of 2 is equal to a half. So I need to divide by square root of 2. And here I have a fraction within a fraction. So whenever we do that, our rule is to keep our first fraction, change from multiplication to division, and flip our second fraction over. So keep, change, flip. So currently, how this reads is 1/2 divided by square root of 2. I am going to keep, change, flip what I have written here. So this would be 1/2 is what I keep. I change from division to multiplication, and then I have to flip that second part over. So currently it's square root of 2 or square root of 2 over 1. So if I flip that over, that would become 1 over square root of 2. So now I just multiply the two fractions. In the numerators, we have 1 times 1. In the denominator, we have 2 times square root of 2. Again, we need to rationalize that denominator. So we are going to end up with x is equal to, in the numerator, 1 times the square root of 2, or just the square root of 2, over 2 square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2. And we would need to multiply those two terms together to get square root of 2 over 4. So since that's the value of x, both sides AB and BC are square root of 2 over 4.